movimento molto più ampio di quello che sono i nostri ricercatori, i nostri allievi, i nostri docenti, e che ci vede quindi più che mai coinvolte in questa iniziativa a livello paese ma anche a livello internazionale. Quindi chiedo a Roberto di introdurre la giornata di oggi.
Ok, grazie mille Sabina. Prima di tutto volevo dirvi che c'è un piccolo cambiamento nel programma, quindi abbiamo deciso di spostare il coffee tea break alla fine della giornata, quindi avremo la mia breve presentazione, la presentazione di Laura Turner, poi una round table discussion e finiremo verso le 4:15, 4:30. Okay, now I'm going to switch to English. So we have moved a little bit the program. The tea coffee break will be at the end of a day, which should be around 4:15, 4:30 maximum. So I will first of all want to introduce Adair Turner, and then I will give my presentation. So first of all, let me say I'm extremely happy to welcome Adair Turner, Lord Turner here at Scuola Superiore Sant'Anna. Adair Turner has been playing a key role in the UK in many different areas, but given that we are talking about climate change, he played a very important role in establishing the UK Climate Change Act in 2008. The UK Climate Change Act is a framework law that actually binds the government to reach emission targets. The UK is farther advanced than Italy in trying to reach this, and it's thanks also to the work of Adair Turner. Adair has a degree as a double first in history and economics from Cambridge University. He worked as an economist and in many different areas. He was the chairman of a financial service authority in the UK. He was the chair of a climate change commission, and now keeps playing a very important role in trying to drive the world towards a decarbonized economy. He is member of the House of Lords, and so he's a very influential role. He plays a very influential role, and I'm very, very happy to have him here. So thank you very much, Adair, for coming. And so now I'm going to give a short introduction to the day. So if from la regia potete mettere la mia presentazione, please. Sì, sì, sì. Okay, thank you very much. So I thought of starting the day by giving you a few facts about climate change, and then I will introduce this initiative on climate change of the Scuole Universitarie Federate, which is Scuola Normale Superiore, Scuola Superiore Sant'Anna, and Istituto di Studi Superiori di Pavia. No? Okay. So, first point that I want to make, and to remind everyone, is that the greenhouse gas concentration continues to rise. We got now to about 415 parts per million. Never in the past 2 million years the world has experienced such high levels of CO2 concentration. And we know this as a fact, facts based on observations coming from tree rings up to a few hundred years ago, ice cores up to a few 100,000 years ago, and then by looking into examining rocks and so on. So this is one of the facts that it's undeniable. We continue to pump greenhouse gases and especially CO2 in the atmosphere. Yeah. And the net effect of this is that the world continues to warm. What I'm showing here is the anomaly, the temperature anomaly for August 2019, data from the Copernicus Climate Change Service. On the right, you see that on average, Europe was warmer than the average temperature of the past 40 years by about 1.1 degrees. On the left of the screen, you see the trend coming from observation and the reanalysis generated from the European Center that clearly shows that over Europe, on average, we have already reached an average warming of about 2 degrees in the past 20 years. So, and clearly, the fact that the world is warming has a lot of implications. For example, sea ice is melting very fast. This year, we have reached the second lowest level of ice extension in the Arctic. As you can see from this image, what you see in white is the ice extent in the Arctic as in August 2019, again data elaborated by Copernicus. In red you see where it was on average between 1981 and 2010. 35% of the sea ice extension over the Arctic is gone. The effect of climate change is to induce a more energetic atmosphere. There is more energy in the system, there is more moisture in the system, more energy in the system also due to an increased sea surface temperature. This leads to very intense phenomena. For example, this is an image of Hurricane Dorian when it was crossing Bahamas. So this type of extreme events clearly are intensifying more if the sea surface temperature is warmer. A warmer sea surface temperature that extends farther towards the extratropics means that phenomena like this can develop and travel, keeping their intensity farther to the north, and so hit farther into the extratropic, Northern America, and so on. Italy, in particular, is one of the countries more exposed to damages linked to extremes. This graph comes from the European Environmental Agency. It shows the damages due to extreme weather events between 1980 and 2017. I just wanted to show it to you to remind that Italy is a very exposed country. It's a very exposed country, as you can see, about 65 billion euros of damages among this year, second only to Germany. This is one of the reasons why Italy as a country, I think, needs to take it very seriously, take a leading position, and really drive a decarbonizing policy. Why climate change must be addressed is not only because more extreme weather events are going to hit everyone, but it's also because the population, the world has never experienced such a large number of population. We are reaching 7.5 billion people, which means that there are hundreds of millions of people living in countries where, if climate change happens as it's projected to happen, they will have to, in some way, escape and migrate somewhere else. We are now facing a large number of migration from Northern Africa into Europe, while with a warmer climate that would make Northern Africa and even more inhospitable and even a place where people will escape, we will be most likely facing millions of people trying to migrate. So it's also in the economic interest of Europe and of everyone that we try to address this problem as urgently as possible. But unfortunately, what we see is that clearly there is a demand for energy because everyone wants to develop, and what we detect is that the annual mean growth rate of CO2, due to this fact, that the fact that there is an increasing demand of energy, keeps going on. This is a huge problem. We need to be able to find a way, and I'm sure Adair will touch into this, we need to find a way to give access to energy to everyone, especially the poorest country, but reducing the mean growth rate of CO2. We need to really transform the way we generate energy, we transport people so that we reduce the growth rate of CO2, eventually reaching zero growth rate and reversing it. And it's not an easy task to do. Why? Because it affects a lot of human activity, if not all of them. We need, I think, to think of transforming the economy and launching what I call Industry 5.0, which is essentially Industry 4.0 minus CO2 by decade. So we need to add on top of all the planning for an Industry 4.0 also decarbonization. Are we responsible for climate change? Yes, we are. There is increasing evidence that that the human activities are the main responsible for the warming, and this is an example of results from studies done by scientists that clearly show that if you don't take into account the amount of the increase in greenhouse gases, you cannot explain the observed trend in warming. So whoever says that natural variability is the main cause of what we see is wrong. Okay, so let me conclude by mentioning what we are trying to do here with Scuola Normale and Istituto Ius Pavia. We are really trying to look into these aspects within this center that we call the Center for Climate Change Research and Sustainable Actions. We want to look into the weather system, so study the mathematics and physics of the system, and look also at the impacts of climate change on different human activities, and try to design strategies that can lead us towards a transformation of the way we live, we produce energy, we move around, we work. Okay? The aim of a center is to identify sustainable actions to manage the key challenges linked to climate change. We are developing a research and an innovation program and an education and training program. And at the same time, we are trying to build strong international links. An example is our reach towards Lord Turner. We are working with the Grantham Institute of London, and we are taking part in international projects. For example, we just submitted a project to the UK BIS Institute. We are in discussion with the Grantham Institute to try to look into organizing, helping them organizing COP26, which most likely will happen between Italy and England. So, in conclusion, and then I want to pass the floor to Adair, I would say that we have a technology and the resources to address climate change, and we will hear from Adair about this. We really need to drive forward an agenda and take the decision that can lead us to this new industrial revolution. We need to change the narrative also. Instead of talking about the cost of addressing climate change, we need to talk about investing to address climate change and grow and lead to economic growth. The initiative that we are putting into place here wants to contribute, and it's the answer in some way of the Scuole Universitarie Federate to the challenges posed by climate change. So with this, I thank you all. I hope I've given you more or less an introduction of why we are here, and I will pass the floor to Adair. Thank you very much. Yeah, it's counterintuitive.
Yes. Roberto, thank you very much for that introduction, and it is an enormous pleasure to be here at the Scuola Sant'Anna. I've become aware of the extent to which it is a leader in many areas of applied research, and I think this initiative to set up a interdisciplinary school related to climate change is immensely important, because to deal with the climate change challenge, we need to bring together the insights of physical scientists and social scientists, economists, people thinking about agriculture, people thinking about technology, in order to work out the solution to what I think is a solvable problem, but one where I am still worried that unless we get the policies right very, very soon, we will not solve. I'm going to talk a little bit about the work and the insights from something called the Energy Transitions Commission. It is a commission which I chair, and it is a global commission, an alliance of both major companies and major environmental NGOs, trying to work out how we can build a low and eventually a zero carbon economy which can deal with the problems of climate change. It's a commission which is working as much in China and India as in Europe and the US. I will not talk in my lecture about specific countries, China and India, but if people want to ask questions later on that, I'm very happy to answer them. What I'm going to do is run through 5 points. First, a point about the scale of the challenge, both climate and the economic challenge. Secondly, about technologies and about why we can be certain that we can get to net zero emissions. Thirdly, about the changing shape of the global economy, and that point that Roberto made about Industry 5.0, and I'll give away the story right up front now, it's about electricity. This is a story about the electrification of the global economy. Fourthly, I'll talk about the economic costs and the investments required to build a zero-carbon economy, and then I'll end with some comments about policies. But let me begin with a comment about climate change. I mean, Roberto has already mentioned the challenges which climate change are producing. One of the challenges that we have is that some of the short-term impacts can be counterintuitive. This is a picture of the extraordinary deep freeze which happened in Middle America and in Chicago earlier this year, which counterintuitively was almost certainly the product of climate change, global warming, because it is destabilizing the polar vortex, which keeps the cold air in the Arctic area and producing these extremely cold blasts south, even while there is very average heating elsewhere. But of course, there are some people who do not believe that story. And this major technical climate expert has recently given us his point of view of what is going on in the Midwest. In the beautiful Midwest, wind chill temperatures are reaching minus 60 degrees, the coldest ever recorded. What the hell is going on with global warming? Please come back. We need you. So we still have a problem of dealing with people who respond to the volatility of the climate system by denying that the problem exists. But if you had been in Australia earlier this year, facing temperatures of over 50 degrees, and with large amounts of Australia suffering wildfires, you would have been more convinced. And indeed, I was in India in June, and the temperatures in the northern Indian plain were going above 50 degrees centigrade, and the northern Indian plain at 50 degrees centigrade is essentially unlivable for human beings. So I believe, and my commission believes, that the climate science tells us that something very big is going on, and we believe that if we don't solve this, it will be bluntly catastrophic for human welfare. Now the question then becomes, what is a safe level of global warming. The Paris Climate Agreement committed the world to trying to keep a warming to below 2 degrees above pre-industrial levels. And we are now where, Roberto? About 1.2, 1.3 degrees already. And that could be our target, but recently the International Panel on Climate Change argued that ideally we should be limiting it to 1.5 degrees centigrade, because the way that the harm from climate change works is that it's very non-linear. As we go from 1 degree to 1.5 degrees, there's a certain amount of harm to human welfare. When you go another half degree from 1.5 to 2, it is a much bigger hit to human welfare. And then there is a point somewhere beyond 2, and certainly by the time we get to 3, where there are huge and potentially catastrophic effects for human welfare. So the IPCC argued that to be safe against really huge harm to human welfare, we had to limit it to 1.5 degrees centigrade. If we were to do that, what does that mean for emissions? Well, one of the challenges that we have in communicating things to the general public is that there are an infinite number of particular paths of emissions reduction which might be compatible with limiting global warming to below 1.5 degrees centigrade, because formally what matters is not just the rate in any one year, but the cumulation over 30 years, the integral of the curve that we're looking at. But broadly speaking, and that's why when the IPCC set out what we have to do to global emissions to be compatible with staying below 1.5 degrees, there are a whole series of different lines. These are just different modeled attempts, each of which would be in different ways compatible. But broadly speaking, you can see the broad pattern, which is almost all of them say that we've got to get below zero emissions, we've got to get down to zero emissions by about mid-century. And the way that we've interpreted that on the ETC, the Energy Transition Commission, is that we should get the world to net zero emissions in the industrial economic system by mid-century, and specifically we've said net zero in the developed world by 2050, by 2060 in the emerging economies. And the story that I'm going to tell you today is the good news that it is absolutely technically and economically feasible for the global economy to reach by 2050 net zero carbon emissions from the energy and industrial systems without relying on large offsets from land use. Because one of the things that I have to tell you is that a lot of models which are produced of how we're going to get to net zero still have very large consumption of fossil fuels, because they simply assume that by 2050 or 2060 we will be reforesting large amounts of the world, or we're doing large amounts of carbon capture and storage, and by putting those large negatives into the model, they say it doesn't matter if we continue to burn a lot of fossil fuels. We have not done that in our modeling. We are talking about a story which gets to net zero. But I have to tell you that my point of view about the world is not quite as optimistic as that suggests. And let me crystallize it like this. I am 99.9% certain that if there was a benevolent dictator of the world, and of course I am volunteering for that role, if there was a benevolent dictator of the world who could design an optimal policy, we would build a zero-carbon economy by 2050 or 2060, and the cost to human living standards would be so small that we would hardly notice it. It's technologically possible at a low cost. 99.9% certain of that. My estimate of the current probabilities that we will do that is no higher than 30%. I think we will probably fail. At the moment, on the trajectories that we are at, we are heading towards 3 degrees centigrade warming. We are not putting in place the policies required to achieve what we could achieve. My commission is trying to work out how do we increase that probability of success from 30 to 35 to 40. And I think the challenge is not political. It's not technological, it's political. It's a problem of not having the policies in place to unleash the technologies and the developments which could, in technological terms, get us there. So that is all that I'm going to say on the issue of what the challenge is. I now want to turn to the technologies that get us to net zero emissions. And I'll begin with a very optimistic part of the story, which is decarbonizing electricity. Can I just go back to that one? It's very sensitive, this machine. You have to, oops. I'm going to talk about decarbonizing electricity, decarbonizing heavy industry, transport, and the cost to consumers. The good news is decarbonizing electricity. The cost of renewable energy has collapsed in the last 10 years. The cost of a new wind turbine or a new solar photovoltaic panel has come down by 60% or 70%. As a result, the cost of producing a megawatt hour of electricity from solar PV has come down by 80%. And one of the interesting points to make is that almost nobody in any official document predicted that 10 years ago. As Roberto has said, I was the first chair of the UK's Climate Change Committee. We produced analysis back in 2008 of what we thought would happen to the costs of different technologies. And those included predictions of the pace at which the cost of wind and solar energy would come down. I have to tell you that I hope people have destroyed the copies of our initial reports because they were so embarrassingly wrong. We knew that the cost of wind and solar would come down 20 or 30 or maybe even 40%. That was the wild optimists. But none of them has predicted it would come down by 80%. And what this illustrates, and it's a very important point to understand in the economics of climate change, is that the costs of future reduction in emissions, they're not given in advance. They are, in technical economic terms, endogenous. If we decide to dramatically reduce emissions and to invest in the technologies which are required to reduce emissions, that will in itself drive down the cost of those technologies in a dramatic fashion. And what happened with wind and solar was that some governments, and it was particularly the German government, and they should be congratulated for this, subsidized solar in its early stages when it was very expensive. They were paying Bavarian farmers 40 cents a kilowatt hour to put panels on their barns at a time when you could have electricity from coal plants at 7 or 8 euro cents per kilowatt hour. But now the price of electricity from solar PV is below the price of coal-fired electricity. And that reflects the fact that as the development of the industry of solar PV got going, it achieved such economies of scale and such learning curve effects in the technology that the costs came down and down and down. And the other area where that has occurred is in the costs of batteries. Battery costs have come down by 80% between 2010 and 2018, and they will undoubtedly halve again by 2024 and probably halve again by 2030. And this is, of course, crucially important because the crucial issue with electricity, with renewable electricity, is what do you do when the wind doesn't blow and the sun doesn't shine? In terms of the cost to deliver a kilowatt hour of electricity, renewables are now cheaper than fossil fuels, but of course, they produce those kilowatt hours when they want, not when we want. So the big challenge, and it's really the only challenge in the electricity systems, is how do you balance the system? How do you end up balancing supply and demand in a system where, unlike with a coal plant or a gas plant, you can't just press a switch and bring on extra delivery? The good news again, however, is that there are answers to that challenge. Within what we call the flexibility challenge within a renewable electricity system, there are problems of what is called ramping. Ramping is how you very, very rapidly increase electricity supply into a system when another bit of the system goes down. So in California now, a lot of solar in the system, you get to sunset, the output of the solar panels collapses in the course of just 10 minutes. How do you very rapidly offset that? And actually, we can deal with that essentially with batteries. Batteries deal very well with the ramping problem. There is a problem of daily or hour-by-hour variations. For instance, again, solar PV in California. A lot of people come home in the evening and they switch on air conditioning systems. You suddenly get an increase in electricity demand just as the electricity supply is going down. Now, those sort of daily variations are increasingly dealable with batteries because batteries are getting so cheap. But what is actually more difficult is seasonal variation. For instance, in the UK, a northern latitude country, where our electricity demand, if we electrify heat, is much higher in January than it is in June, and where in the winter seasons we don't have so much solar energy. And although we tend to get wind energy in January and February, every now and then there is an anticyclone, and then we have a week where we hardly have any wind energy. So for that, you need longer-term storage. But we do have solutions to that, what's called dispatchable hydro. You might have nuclear as a baseload. You might keep a small amount of thermal plants, in particular gas plants, only running 10% of the hours in the year, but equipped with carbon capture and storage to make it a zero carbon. There is the possibility of using hydrogen as a balancing item, and there is the possibility to get much more smart about demand management. At the moment, because our power systems have been built on thermal dispatchable plant, we've got used to the idea that we should just press a button and use electricity whenever we want it. But there are lots and lots of bits of industry that don't need to do that, which could make a contract with the system to accept electricity when it's surplus. In most homes, if they are heated by electricity, it doesn't matter whether the heating is on at a particular half-hour period, as long as there's a steady build-up of heat during the year. And in particular, once we have large amounts of electrical vehicles with batteries in them, one of the most crucial things is getting people to be sensitive to the system in terms of when they charge their electric vehicles. We want them to plug them in the evening, and then clever software telling them when to charge in the middle of the night, rather than individuals doing it without thought. When you put together all of those different ways of balancing the system, we are absolutely confident that we have ways of making electricity fully compatible with fossil fuels. Our analysis suggests that in almost all geographies, and even if all that you had were battery and what are called gas peaking plants, we can deliver electricity when it's needed at an average price of $70 per megawatt hour. We think that that is lower still in parts of the world which have favorable resources such as dispatchable hydro. By the way, what I mean by dispatchable hydro is hydro behind a dam. There's a thing called run-of-river hydro, which is running whenever the river is running, but you can't switch it on and off. But if it's behind a dam, you can switch the turbines on and off, or if you have sophisticated demand management. But it is also important to realize that there are some geographies where electricity is going to be far cheaper than the figure I suggested earlier. I showed a chart earlier which showed the cost of electricity from solar coming down by 80% and at $60 a megawatt hour. But in the most favorable parts of the world, there have recently been auctions, this is in Saudi Arabia and in Mexico and Chile, with people committing to deliver solar energy at less than $20 per megawatt hour. That is how low the auction prices have got in the most favorable parts of the world. And there will be parts of the world as a result where electricity is available on a 24/7 basis at less than $35 per megawatt hour, when you've added in the cost of flexibility and backup. So all of that is good news. Electricity, we know how to decarbonize it. We know how to have it at a cost which is fully competitive with fossil fuels and in some places below the cost of fossil fuels. And therefore, the essence of a strategy to build a zero-carbon economy is to decarbonize electricity and to electrify as much of the economy as possible. At the moment, when we use energy as final energy users, only about 22 or 23% of that, on average across the world, is electricity. And the others is petrol or diesel or coal. We believe that that percentage of how much of final energy demand is met by electricity will have to go up to about 60 or 65%. This is a new industrial revolution of electrification, and it has huge benefits, and it's a huge step forward in our ability to decarbonize the global economy. But it still leaves a problem, which is what to do in the sectors of the economy where it's not so obvious that if you just had clean electricity, you've won the war. If we have clean electricity and we all run electric vehicles, then we have zero carbon surface transport. But what about the sectors of the economy shown on this chart? Heavy road, long distance traffic, trucking, aviation, shipping, iron and steel, cement, chemicals and petrochemicals, and aluminium. In total today, those sectors account for 30% of global emissions. And if we don't take radical action on those sectors, that percentage may increase dramatically. Indeed, in the middle chart here, which is what is called the IEA, the International Energy Agency reference, a sort of business as usual scenario, they see that increasing to over 40% of global emissions and maybe even higher by 2050. And that's because, simply, as we deal with the easy bit of the economy, which is decarbonizing electricity, dealing with this becomes a more significant challenge. So I'd like to make some comments now about how do we decarbonize heavy industry and how do we decarbonize long distance as against, and heavy duty as against a light duty car transport. First of all, decarbonizing heavy industry. When we think about it, we should think about three things that we can do. One is to reduce demand for carbon-intensive products and services, to make buildings with less need for concrete. And there are a lot of people who've looked at the way we build our buildings and said you could build just as robust a building with 40 or 50% less concrete, because we've never really thought about trying to minimize the use of concrete, so architects just don't optimize building design to reduce the use of concrete. They just say, I'll just pour some more concrete because it's pretty cheap. We, across all of these sectors, we have major opportunities to reduce demand. The other thing that we can do, number two, is we can just improve energy efficiency within the existing technology. Now, there are opportunities to do that, but of course in these sectors of the economy, energy is quite a large percentage of the total cost of production, and managers have been trying to reduce energy cost already. These are tightly managed sectors of the economy. So yes, we can probably squeeze another 15% or so out by energy efficiency within the existing technology, but there's a limit to what we can do there. And to go beyond those limits, we need to apply 3/4 technologies. The three fundamental technologies are: we electrify things, we add carbon capture and storage at the back end of an industrial process, or we use bioenergy rather than fossil fuel energy. And then the fourth one, and the reason why it's a bit separate, is a derivative of the others. We use hydrogen. Hydrogen is made either from electricity, electrolysis, or you make it from steam methane reforming. You start with CH4, methane, and you add carbon capture and storage. So hydrogen, and I'll come back to this, is a very important part of the story, but it actually itself depends either on electricity or on the use of carbon capture and storage. And the good news is that when you think across the major industrial sectors. And we've set this out in this report, which we've called Mission Possible, which the key messages are in the title. When you think across each of these heavy industrial sectors, it is possible to decarbonize them at an affordable cost. Let me give you just 2 examples. I won't take you through all of them. In the area of steel, we start at the moment with blast furnaces which use coking coal, also called metallurgical coal. It's a very high energy-intensive coal. And that coal is performing 2 functions. It is providing heat, but it is also providing carbon as a reduction agent. You start with iron ore, it has oxygen in it, and essentially the oxygen leaves the iron ore and combines with the carbon, but as a result produces CO2. So part of the CO2 coming out of steel mills is part of a chemical process, a reduction process, a movement in the oxygen atom from one molecule to another, and part of it is heat. We also have what's called direct reduction using syngas, which is a combination of carbon monoxide and hydrogen, and we have electric arc furnaces where you recycle steel. Now, how can we decarbonize this sector of the economy? We could add carbon capture and storage at the back end of a coking coal blast furnace. And we will probably do that in some parts of the world. We could use hydrogen as a reduction agent, because just as the carbon atom can, as it were, pull the oxygen out of iron oxide and leave the iron behind, so too can a hydrogen atom. But the great news is that a hydrogen atom combined with oxygen is just water, steam, water vapor, rather than CO2. So when we switch to hydrogen as the reduction agent, we have a zero carbon solution. There are also people looking at the use of direct electrolysis in iron ore to directly electrolyze it in the same way that we do with aluminium. Or we can do far greater recycling of steel in order to use electric arc furnaces. And when we use electric arc furnaces, as long as the electricity is zero carbon, the steel is zero carbon. Now, I'm not going to go in through all the details of that, but our analysis says each one of these routes is possible. Each one of these routes we could have in place by 2040 or 2045 across the world. For instance, there is a Swedish company called SSAB, which is building pilot plants already to use the hydrogen route with a clear public commitment that it will be producing zero carbon steel by the early 2040s. So we can do this. This is possible. It's possible for steel. It is also possible for cement. I won't go through that. And it is also possible for plastics. Indeed, plastics is a very interesting one, because in plastics there are ways to decarbonize the production process, for instance by using electricity as a heat input, or using biomass as a feedstock rather than oil or gas. But actually it's in plastics where there is the greatest opportunity to reduce our primary production demand by really getting serious about recycling. If we make sure that every bit of plastics that we have is recycled, then a significant amount of new plastics can be made out of old plastics. That's sometimes in the form of what's called mechanical recycling, where you're taking a particular a polymer, like a PET or a polyethylene, and you're simply melting it down in its own form. Or there is chemical recycling. It's more energy intensive, where you are breaking it down to the fundamental molecules and rebuilding it. But both are possible. So the message I would have on industrial decarbonization is we are absolutely convinced that it's technically possible. And not just us. Every time I talk to a steel company or an aluminium company or a cement company and say, we think this is technologically possible, they say, yes, it's technologically possible. We can do this. All of the issues about how much does it cost to do it. And I'll come back in a minute to how much does it cost. Let me turn to decarbonizing transport. Here, there is a distinction between heavy road transport, shipping, and aviation. Heavy road transport, and I didn't know 3 years ago that I was going to be as confident as I am in this production. heavy road transport, as well as light-duty transport, is going to electrify. Now, for long-distance trucking, it may electrify in the form of a hydrogen fuel cell driving an electric engine. For shorter distance, it will be batteries, but it will go electric. And indeed, automobiles will go electric very, very fast. And the fundamental reason why this is going to be the case is that electric engines are much, much more efficient than internal combustion engines. When you run an internal combustion engine, and it depends how you drive it, but depending on how you drive it, somewhere between 60% and 80% of the energy you put into an internal combustion engine will not turn into kinetic energy turning the wheels, it will turn into wasted heat. And that is inherent to the thermodynamics of a thermal engine. With an electric engine, 95% of the energy that you put in as a battery or as the electricity coming out of a fuel cell will turn the wheels, and only 5% will turn into wasted heat. And eventually, once we have got batteries better, that will win. The only reason why we ever had internal combustion engines is that the energy density of a litre of gasoline is so much higher than the energy density of a litre or a kilogram of battery. Essentially, we should think of an internal combustion engine as a really rather inefficient engine attached to a phenomenally dense supply of energy, and an electric engine as a fantastically efficient engine attached up until now to a rather heavy battery. But once we crack the battery problems, this will electrify. And indeed, trucking is one area of the economy where this will cost the economy nothing. That electrification story is also important for shipping and aviation at short distance. There are people out there who believe that airplanes, even as far as 100-seaters traveling 500 kilometers, could electrify in battery electric. But nobody at the moment thinks there's any chance of getting a jumbo jet to fly across the Atlantic with a battery. The calculation is that if you were to do that, you would have to need a battery which weighed 250 tons, which, considering that the whole jumbo jet without any fuel weighs 250 tons, is quite a penalty to take. And with the disadvantage that, unlike fuel, where you start with about 50 tons, and when you get to land, you've only got 5 tons left, with the battery, it'll still weigh 250 tons when you get to the other end of your journey. So we don't think that battery electric will work for long distance unless there are unknown technological breakthroughs in energy density which just transform the picture. They may occur, but we would not rely on those. But with aviation, we could use biofuels or synthetic fuels. It is absolutely possible today, not in the future, but today, to make the precise chemical equivalent of conventional jet fuel, either from a bio source or from a synthetic source, synthesizing it out of CO2 captured from the air and hydrogen, and to run planes on 100% mix. And we have talked both with the chief technology officers of Rolls-Royce and Boeing, and they have confirmed to us that that is possible today. There is no problem of running 100% biofuels today. So the question is, what is the cost of doing that? As for shipping, again, this was one I had no idea I was going to say 3 years ago. We may run ship engines on ammonia. Ammonia is made out of hydrogen. If you make the hydrogen in a clean fashion with electrolysis, your ammonia is clean, and ship engines can be converted to ammonia with relatively little a change to the engine. So the good news is that when you approach all this in technological terms, we have answers to how to decarbonize even the really tricky sectors of the economy. So the crucial thing is, what does this cost to consumers, and what does it cost to industry? And the most important point I want to make here is that the answer is different for consumers and industry, and it illustrates what we call the conundrum of competitiveness. You can think about costs in terms of how much does it cost to take a ton of CO2 out of these industrial processes. And some of them are easier to decarbonize than others. Actually, steel, if we had carbon prices in place today of, say, $50 or $60 per ton, which is not much higher than they are already at in the European emissions trading scheme, steel will decarbonize. It's not one of the most expensive. It's one of the cheaper ones to decarbonize. Cement is more expensive. Decarbonizing ethylene production, which is one of the precursors for plastics, looks like quite an expensive thing to decarbonize. Trucking will decarbonize for nothing eventually. Eventually, because of that efficiency of electric engines, we will buy our trucking services for less economic cost than we do at the moment. Aviation is more expensive. Shipping with ammonia looks like one of the most expensive sectors of the economy to decarbonize. So the costs are different by different sectors of the economy. But when you run those through to what does it then imply for consumer living standards, it's really not very worrying. Because if you asked, oops, I'm going to go one further. If you asked, if you decarbonized plastics production, even at the expense I showed on the previous chart, what will that do to the cost of a litre of Coca-Cola? The answer is well less than 1%. Because at the end consumer use, the cost of plastics doesn't make much difference to the thing that they are consuming at the end. Even with steel, even if we assume that it will cost $50 or $60 a ton to decarbonize steel, and it may cost much less, a car, an automobile, made out of zero carbon steel will only cost less than 1% more than it does at the moment. And if you go across all the sectors of the economy, the implications for decarbonizing, for consumer living standards, are just not that big. And you'd have thought that, given the worrying stuff that Roberto told us about the dangers of climate change, if we said you can avoid those dangers of climate change and you'll have to pay 1% more for an automobile, spread over the next 20 years as we head towards it, we ought to be able to persuade citizens to take that cost. There is one exception, which is, as best we can tell, if we want to decarbonize aviation, we will have to accept a higher cost of aviation, but not twice as much, 10 or 20% as much. And we'll have to persuade people that that is one area where consumers will have to pay. The challenge is, however, that seen from the industrial point of view, at the intermediate product level, the costs are large. So let's think about steel. This will add only 1% to the cost of a car made out of green steel, but at the level of a ton of steel sold by a steel company, it could add 20% to the cost of a ton of steel. And that means that if one steel company goes ahead and decarbonizes and accepts a higher cost production process, and their competitors don't, they can be bankrupt, even if at the level of the consumer it's not of a problem. So we have this difference between, at the level of consumer living standards, this is not a major problem. At the level of the cost of intermediate goods and industrial competitiveness, it can be quite a challenge. And I'll come back to later what we do about that. Let me now just make some comments about the shape of the global economy that comes from this. I said earlier that there were 4 major new technologies which we could think about as driving this decarbonization process: electricity, biomass, carbon capture and storage, hydrogen. They're all important, we need all of them, but essentially 2 of those, I think, will account for 75% of what we do: electricity and hydrogen. This will be a massively more electrified economy. Our calculations are that in order to build a zero-carbon economy across the world, we will have to take total global electricity supply from today's level, which is on the left here, about 23,000 terawatt hours, to somewhere between 86 and 115, say 90 to 110,000 terawatt hours of electricity. The range reflects how smart do we get at reducing the demand for energy-intensive materials. If we get really smart, it may be as low as 86,000 terawatt hours. If we're not smart about recycling our plastics and designing our buildings later, it could be 115,000 terawatt hours. But either way, think about electricity across the world becoming 4 or 5 times bigger than it is at the moment. This is a story about massive electrification, and it has huge potential byproduct effects as well. Cities in which all the transport is electric are just going to be much nicer cities to live in. They're going to have much less pollution. They're going to have much less noise. In hot days in summer, they won't be quite as hot, because remember that those internal combustion engines, they're taking 70% of the energy and turn it into heat. In London, when it was 35 degrees centigrade in July, it was insufferably hot, and we were making it hotter because we had 100,000 cars, automobiles, going around town. I describe them as 100,000 mobile patio heaters, which we have just decided to circulate round and round town to make the city even hotter than it otherwise was. There are huge potential benefits from having an electric economy, because electricity really is the magic technology. At its end point, it really is, as best we can tell, zero pollution. It is silent, it produces no emissions, and as long as we produce it in a good fashion, it's completely pollutionless all the way through. The other thing which we will do, however, and you can see that in the green and the brown, is use electricity to produce hydrogen, and then to produce ammonia through the Haber-Bosch process. And we think that it is quite possible that the future global energy system will involve a 10 times increase in the cost of, in the amount of hydrogen we produce. At the moment, the world produces about 60 million tons of hydrogen. We could see that going to 600 million tons, or 650 million tons, and we think that's possible even if there are very, very few hydrogen automobiles. The story about hydrogen has been a bit of a sort of diversion. People got fixated with whether hydrogen cars will beat battery cars. For most people, battery cars will beat hydrogen cars. But even if there are very few hydrogen cars, there will be a lot of hydrogen used in our economy to reduce steel, to be used in petrochemical processes, as a balancing item within the power system, using surplus power to make electricity, to make hydrogen when the sun is shining and the wind is blowing, and then turning it back into electricity when we need it. So we are going to have to build a world of massively more electricity. And people often say at this point, well, oh, where's the space to put all the solar panels? There are many things to worry about in the world, but adequate space for solar panels is not one of them. Every day, the sun, which of course is a giant nuclear fusion plant usefully placed 90 million miles away, so it's a rather useful thing that God has done there. Every day, that fusion plant up in the sky radiates down onto Earth 8,000 times as much energy as the entire human industrial and economic system. So all we have to capture is 1 out of 8,000 of that. And once you realize that, it's not surprising that the land use needs for solar PV panels are not in the slightest bit worrying. At the level of the overall world, you can think on average that you need about 32 kilometers squared to have about a gigawatt of a solar capacity. At a certain assumption, about thousands of hours per year, and the yield, that means you need about 1.6 hectares per gigawatt hour produced. If you run through the figures, 100,000 terawatt hours would require 1.6 million kilometers squared, which is about 1% of the global land surface area and about 0.3% of the global surface area if we also worked out how to put solar panels on the oceans. So tonight, worry about many things, but do not worry about sufficient land area to put solar PV. Though you may worry about particular countries. China can produce all the electricity it needs with only 1% of its land area devoted to solar panels or wind turbines. And it has lots and lots of land in west and northern China which has almost no other economic purpose, and that therefore the cost of land is zero. If Bangladesh, with a population density 10 times that of China, was to try to provide all its electricity with solar PV, it would have to cover 5 to 8% of the land area of Bangladesh in solar PV panels, in a country where every single hectare of Bangladesh is already used for food production or human habitation. So there is no problem at the global level. There are some challenges for individual countries, and this raises some big issues about will we and should we see a new international trade in either hydrogen or electricity to replace the trade in oil and gas that we have today. Let me make some comments now about the economic costs and investment required. And I'll deal first of all with the costs, small relative to GDP, the incremental investment, small relative to global savings and investment, and a few points about the financial challenges that nevertheless exist. When we ran the figures for what does it cost to decarbonize these harder to abate sectors of the economy, we end up with estimates which, depending about whether you believe a low-cost scenario or a high-cost scenario, depending on whether we'll get really serious about recycling and energy efficiency, you can produce a range which goes from 0.2% of global GDP to 0.45% of GDP, but you can't produce much higher figures than that. And when you add in the costs of decarbonizing residential heat, didn't mention that, but that is one of the more expensive ones, and the costs that you need initially to decarbonize the electricity system, our analysis strongly confirms Nick Stern's argument in his book on the economics of climate change that we can decarbonize the global economy at a cost no more than 1 to 1.5% of global GDP. And a way to think about that is global GDP grows at about 3% per annum. So if it costs 1.5% to decarbonize it, then the world has to accept that on average across the world, it will have to wait till December 2050 to get to the standard of living which it would otherwise have reached in June 2050. It's a half a year of 3% growth given up. And again, that doesn't seem an astronomical cost. Indeed, it seems a trivial cost to avoid potentially catastrophic impacts of climate change. However, we shouldn't simply say that and say, well, okay, that means that there's no problem at all, because within, let's say it was 1% or 1.5% cost, there are winners and losers. And the winners will say thank you very much, but they won't want to pay extra tax out of their winnings, and the losers will object. There are, for instance, different sectors of the economy where things will get cheaper and more expensive. I think within 10 years, all of us will be buying automobile services for less than we are today. We will be both buying automobiles for less upfront capital cost than today, because electric engines are much, much easier to make than internal combustion engines, and we will be put much less energy into them. So automobile services, what the average household pays to own and run a car, is going to be lower. Residential heat is going to be higher, because in order to crack residential heat, we're going to have to insulate our houses better, and people are going to have to buy heat pumps, and heat pumps are more expensive than gas boilers. And that means there's going to be some people who are going to win and some people are going to lose. And the winners might include relatively rich people running very large cars who switch from a lovely top-of-the-range Mercedes to a Tesla and are roaring around the country in a luxury car and paying less than they are today. And the losers may be a low-income family, which already finds it difficult to pay for energy bills, but to whom we are saying, you've got to invest in insulating your house and buying a heat pump to drive a zero-carbon economy. And what that simply tells us is we should have confidence that the cost of building a zero-carbon economy overall is small, but we have to be sensible about identifying in advance the distributional consequences of this for different groups of people and planning what we do with subsidies, with help, with changes in taxation to minimize the losers, if necessary, well, it will be necessary, taxing some of the winners. And of course, that is difficult, but it should be possible, but it requires political vision and political choice in order to drive that forward. As for investment, various people have tried to work out how much more investment do we have to do per annum to build the wind turbines, the solar plants, the new charging infrastructure, the better insulated buildings to build a zero-carbon economy across the world. And one of the challenges is that the range is huge. Some people say it's as low as 200 billion, 0.2 of $1 trillion. Some people that it could be 1.9 trillion. The median of the estimates is about 0.9 of $1 trillion, 900 billion. And whenever you say 900 billion, you know, almost $1 trillion, people go, oh God, how will we possibly be able to mobilize that amount of savings? Well, just beware, $1 trillion is less than 1% of global GDP. And it's less than 4% of global savings and investment. And right today, one of the macroeconomic problems that we have in the world is that there seems to be too much savings, attempted savings, pursuing not enough investment, which is why real interest rates are actually negative. In a world where real interest rates are actually negative, where governments can borrow money for a negative amount, and even where nominal interest rates are negative. I mean, I do ask you to think about this interesting phenomenon at the moment. If you go to the Swiss government with 1,000 Swiss francs and say you would like to lend it to them for 50 years, the Swiss government is willing to give you a completely copper-bottomed guarantee that in 2070 they will pay you back about 900 Swiss francs rather than the 1,000 that you gave them. It's very, very good of them to make that promise. But in such a world of these incredibly low real interest rates, the fundamental problem we do not have, another thing not to worry about, do not worry about the macroeconomic achievability of investing on this scale. In macroeconomic terms, this is not a big challenge. But there still are policy challenges about how to get there. This is a rather busy slide, but just let me try and give you an idea of the 4 points being made. One of the points is that a zero-carbon system of energy has a particular cost structure which is different from a thermal system. Almost all the costs are upfront capital costs, and there are almost zero operating costs. And that means that in order to make the investment economic, you need a lot of certainty about your future revenue stream. And the only way that we manage to get people to invest large amounts in wind farms and solar farms is to give them guarantees of the price that they will get 15 years in advance. We can still use auctions, competitive auctions, to drive that price down, but we need to be clever about the contract structures and the design of electricity markets to create incentives for this particular nature of zero-carbon electricity. We also have major challenges in emerging countries. So, I just said a minute ago that real interest rates are really low. So what's the difficulty of financing investments? There are pension funds and institutional investors there who are desperate to be given a return of 2% rather than minus 1%. Well, it's not like that in India. If you want do an investment in India, the cost of capital is about 10%. And that's because there are all sorts of exchange rate risks, there are incomplete capital markets. So there is a financing challenge in the emerging markets in a way that there isn't in the developed markets. We need large investments in buildings, and one of the problems in buildings is that they have very complicated value chains. You often have a different person who owns the building rather than the person who uses the building. And though you have a problem in economics of split incentives, there's not an incentive for any one person to drive the energy efficiency. And there are then this problem of competitiveness concerns. Let me finally end then with the policies that we need to drive this decarbonisation. And I will talk about these ones. First, I think we need to set ambitious, non-negotiable targets, particularly in developed economies. Roberto talked earlier about the fact that the UK now has a target legally mandated by Parliament. I was in the House of Lords a month ago to pass it through, where we will achieve net zero emissions by 2050. And that in itself is powerful, because once you do that, and once every business in the country believes that that is going to occur, they start changing their behavior to be compatible with getting there. Because they start believing, well, if that's in the law, there will be carbon prices, there will be regulations, and I better anticipate them in my action. So that in itself is important. We also need clear overall strategy, and we need for politicians and businesses to understand that although there are multiple technologies out here, the single most important is electrification. We just need a vision, a joint vision, that we are building a more electrified economy. We need initial subsidies for key technologies. We did that with wind, with solar, with batteries. Initial subsidies. It was expensive, but then the price collapses to the point where you no longer need the subsidies. We need to do the same with electrolysis equipment and fuel cell equipment to drive the hydrogen economy. I think it's likely that in 15 years' time, electrolysis equipment might cost only 20 to 25% of what it is today. I think that's technologically possible, but it will only occur if the scale on which electrolysis equipment is used dramatically increases. We need carbon prices, and ideally we need carbon prices globally, but if we can't have them, we can also use them on a domestic basis, a differentiated basis, and a downstream basis. What do I mean by downstream basis? We have very large carbon prices in Europe on gasoline and diesel. But because they are imposed not on a refiner of gasoline and diesel, but on the consumer, there isn't a competitiveness problem, because they face the tax wherever the refinery which produced the gasoline and diesel was. So you don't have refiners in Europe saying, oh, don't impose that gasoline tax, you'll make me uneconomic relative to a refinery in Turkey. That's irrelevant because we've imposed the tax downstream. But we may also need to think about what I call border carbon tariffs. We are now talking with major steel companies in India and in the UK about encouraging them jointly to tell their governments that they would like there to be carbon taxes imposed at, say, $50 per ton equivalent, but only if those governments impose tariffs against any country in the world which is not applying a similar carbon price. And we have to think about that. We need regulations. Sometimes regulations are more effective than markets. One of the most important things we have to do still in households is get everybody to switch from incandescent light bulbs to light-emitting diode LED light bulbs. They're 80 or 90% more efficient. Now, a neoclassical economist believing in rational economic man or woman would assume that the best way to do this would be to increase the price of electricity so that the ordinary citizen sitting down of an evening to run the spreadsheet on whether the process of buying an incandescent light bulb or an LED light bulb, which had the highest net present value, discounted at an appropriate rate which reflected the time value of money. That is what a believer in rational expectations and rational economic behavior would do. But you have to remember that the person, an economist who believes in rational economic behavior is like the person who walks along a street, he sees a $100 bill on the street, and he doesn't pick it up because he knows it isn't there, because If it was there, someone would already have picked it up. So human beings, as against economists, are not wholly rational. And that tells us that there are some sectors of the economy where the most effective way to do it is simply to regulate, to say beyond date X, you are not allowed to buy an incandescent light bulb, you have to buy an LED bulb. We need blunt targets. I think we should ban the sale of new internal combustion engines from 2030. Now, France has said 2040, UK said 2040, Scandinavian countries are coming for 2035. I'm outbidding them. I think we should do it from 2030. These blunt instruments are sometimes very, very powerful in driving change. And we need R&D support for new technologies. What are the new technologies? I won't go through them. Here are a whole series of them. And I think the point that this set of new technologies make is that there are huge business opportunities in this new economy. There are as many jobs in this new economy as in the old economy. There are business opportunities for business across all of these different technologies. We need to have businesses taking the initiative to drive down the costs, but that will only occur if we have stretching targets, strong regulation, strong carbon prices imposed to drive us in that direction. As long as we do that, I am absolutely confident that we can technologically and economically build a zero-carbon economy, but the challenge now is to have the stretching targets and the policies that get us there. And I hope it will be possible over time to increase the probability that we'll get there from the rather pessimistic 30% that I mentioned earlier to a rather higher figure. Thank you very much.
Thank you very much for a very, very interesting talk. Now I leave the floor to Andrea Roventini, who is going to introduce the people participating to a panel discussion. We will have a few people intervening, then we will give the floor also to the audience. Whoever wants to ask questions is welcome to do so. So Andrea, why don't you take it over for me? Oh, does it work? No? No, I think dai.
Innanzitutto ringrazio i nostri ospiti del panel che avrebbero dovuto essere qui fisicamente, ma sapete che oggi è una giornata particolare perché si vota la fiducia al nostro nuovo governo in Italia e quindi nonostante siano impegnati in impegni istituzionali hanno accettato di collegarsi con noi in remoto via Skype. Quindi sono molto contento di salutare Laura Castelli, deputata della Repubblica, che è stata vice ministro dell'economia nel precedente governo. Dovrebbe essere collegato o sarà collegato a breve anche Antonio Misiani, senatore della Repubblica, capogruppo del PD in Commissione Bilancio e responsabile economico del Partito Democratico. Dovrebbe essere collegata da Washington Nicoletta Batini, economista senior del Fondo Monetario Internazionale, e qui, è qui con noi ovviamente Giovanni Dosi, un'istituzione della Scuola Superiore Sant'Anna. Io organizzerei il dibattito nel seguente modo: farei 2 giri di domande ai nostri ospiti, a cui Adair potrà eventualmente rispondere e via dicendo, poi eventualmente possiamo anche fare, se c'è del tempo, qualche domanda dal pubblico. Mi scuso con Adair per parlare in italiano, ma cerco di rendere il dibattito più semplice. La prima domanda che chiederei ai nostri ospiti è la loro reazione all'intervento di Adair. Io mi sono segnato alcuni punti che penso che potrebbero essere interessanti per i nostri ospiti, ad esempio pensando a Giovanni e a Nicoletta il possibile ruolo del mercato, o l'utilizzo dei terreni, il cosiddetto land use per la produzione solare. Si parla di guerra commerciale, di tariffe che ha iniziato Trump, se si potesse fare una guerra commerciale eventualmente basata sulle tariffe, sulle emissioni di gas serra. Quando Adair ha parlato della possibilità di produrre acciaio a emissioni zero, io ho pensato immediatamente all'Ilva e alla possibile sorte dell'Ilva nei prossimi giorni. Quando si è parlato del costo di finanziare queste politiche per il cambiamento climatico, ho pensato ad esempio al dibattito che c'è adesso in Italia su come fare la riforma dell'IVA, ad esempio se penalizzare certi beni che utilizzano una maggiore produzione di gas serra, oppure il cosiddetto dibattito sui sussidi dannosi per il nostro ambiente. Quindi insomma lascerei ai nostri ospiti di rispondere, di commentare sul talk, sull'intervento di Adair. Non so dove vogliamo iniziare. Vogliamo iniziamo da Laura, dall'onorevole Castelli.
Sì, grazie a tutti dell'invito e di questa iniziativa che è veramente molto interessante e devo dire mai come in questo momento calzante nel tempo e nello spazio. Devo dire che di quello che ho sentito una delle cose che mi fa maggiormente piacere è la chiarezza con la quale si evince che è possibile decarbonizzare al 2050, quindi se i tecnici, chi si occupa di questa materia, gli economisti che sono intervenuti sostengono con forza la possibilità di fare un percorso che oggi per l'Italia e per la politica che è stata fatta fino ad oggi, insomma, era vista come un obiettivo molto lontano, vuol dire che chi oggi sta prendendo le redini a livello politico di questi temi si trova davanti a una battaglia possibile. Ci sono molti aspetti che tu, Andrea, hai sottolineato adesso, molti di quali sono in discussione in questi mesi, sono stati in discussione in questo anno e mezzo affinché si potesse arrivare a questa manovra con una fotografia di una transizione vera energetica e economica. Io mi sono occupata in questo anno e mezzo del lavoro che mai era stato fatto sui sussidi ambientali dannosi insieme a tutti i ministeri competenti ed è stato un lavoro molto lungo e faticoso perché riprogrammare così tanti miliardi di spesa corrente è stato complesso. Oggi siamo a un punto per il quale all'interno della manovra ci sarà la riorganizzazione dei sussidi ambientali dannosi, però con un giusto mix, cioè non si tratta di cancellare delle spese, si tratta di programmare aggregando gli investimenti in alcuni settori che vanno a sostituire quegli incentivi ambientali dannosi per una conversione che nel corso di 5, massimo 10 anni per alcune categorie, parliamo soprattutto di carburante e di quello che è sostegno, diciamo, a un trasporto poco innovativo che ancora lo Stato italiano finanziava. Questo è possibile, ripeto ancora, mettendo insieme una giusta programmazione di investimenti che possa lanciare davvero questa trasformazione e proseguire. Noi l'anno scorso avevamo fatto il bonus malus sulle auto elettriche, molto criticato, però ha dato grandi numeri già quest'anno. Questo significa che quando dai la possibilità, le persone poi seguono quello che la politica in qualche modo gli indica come direzione, e qui la grande partnership tra pubblico e privato. C'è un lavoro che stiamo facendo in questi mesi che è quello di coinvolgere ancora di più le partecipate di Stato fino a che si possano coordinare. C'è una grande mamma in Italia che è Cassa Depositi e Prestiti che coordina le sue partecipate su temi importanti, tant'è che all'interno del piano industriale di Cassa Depositi e Prestiti una grande fetta è riservata a questo mondo, quindi al mondo dell'economia verde e delle riconversioni. Passo passo si può fare ancora meglio, quindi stiamo facendo delle grandi attività di coordinamento con tutte le partecipate. E poi il tema della fiscalità, si parlava di IVA, voi sapete tutti che quest'anno, anche quest'anno c'è questo tema, questo governo non ha nessuna intenzione di aumentare l'IVA, ma sono d'obbligo, e sono d'accordo con voi, tutta una serie di ragionamenti riguardanti alcuni prodotti. Se pensiamo all'alimentare, allora perché non discutere di un alimentare che sfuso abbia un'aliquota IVA più bassa e che invece, se impacchettato e quindi con una forte componente ambientale dannosa, possa costare di più, e il consumatore sicuramente andrà a cercare quei prodotti ambientalmente meno impattanti. E l'altra cosa su cui abbiamo lavorato in maniera, anche grazie ad Andrea, ne parlavamo già molti anni fa, ma adesso è realtà, è l'idea di mettere un addizionale all'interno dell'IRES, la cosiddetta IRES verde, che possa in qualche modo, per la prima volta nel mondo, identificare quelle aziende che si impegnano nella riduzione di impatto ambientale. Oggi in Italia c'è una certificazione che le aziende, soprattutto quelle grandi, devono avere, dimostrando di aver cominciato un percorso di riduzione dell'impatto ambientale. Bene, le piccole aziende ovviamente fanno più fatica, per questo al MISE c'è un fondo dedicato che le sostiene nel finanziamento di queste certificazioni. Credo che sia arrivato il momento, e quindi lo faremo perché l'abbiamo chiusa, strutturata, va solo integrata nella manovra, di inserire all'interno della fiscalità d'impresa un piccolo riferimento a questo concetto. Io personalmente ci tengo molto. Il tema non è fare soldi, il tema è cominciare a raccontare che esiste uno spostamento di fiscalità che deve guardare anche a questa componente. Devo dire, tutte le associazioni di categoria con cui abbiamo parlato sono coscienti che è arrivato il momento, c'è un nuovo governo, c'è una nuova forza che si è impegnata insieme a fare una grande transizione industriale, soprattutto dal punto di vista energetico e ambientale, e quindi io sono molto fiduciosa, insomma anche i colleghi che con me faranno questa cosa sono molto entusiasti. Infatti tra poco poi sentirete il mio collega Misiani, che è anche molto affezionato a questi temi. Quindi c'è stato un grande lavoro in questo anno e mezzo. Devo dire, le strutture dei ministeri sono rimaste un po' da sole in questi anni, c'è stato poco coordinamento, e la prima cosa che si evinceva è che non si parlavano, quindi il Ministero dell'Ambiente non parlava abbastanza con quello dello sviluppo economico, e quello dello sviluppo economico non parlava abbastanza con quello dell'economia. Li abbiamo messi insieme e costretti una volta ogni 15 giorni a riflettere e decidere insieme alla parte politica su questo genere di temi, e oggi possiamo cominciare a raccogliere degli ottimi risultati.
Grazie Laura. Io passerei la parola adesso a Nicoletta Batini, che oltre a essere un'amica è un'esperta anche di agricoltura sostenibile e di transazione verso un'agricoltura più sostenibile, che possa portare anche dei benefici alla nostra crescita economica. Benvenuta Nicoletta, ciao.
Grazie Andrea, mi sentite bene?
Sì, sentiamo bene.
Ecco, innanzitutto ringrazio il Sant'Anna, che è la mia alma mater, per questo invito, che mi fa un piacere immenso. Mi fa ancora più piacere che il Sant'Anna si occupi di questi temi, che sono poi temi non del futuro ma del presente. Un disclaimer per la stampa: se c'è stampa in sala, io sto parlando a titolo personale, non a titolo del Fondo Monetario né del suo direttorio, perché parlerò un po'.
Nicoletta, sentiamo male, non so come mai, vediamo se riusciamo a migliorare. Per te,
mi senti adesso?
Adair ti sente bene? Adesso sì.
Stavo facendo un disclaimer sul fatto che sono presente a questa conferenza a titolo personale e non a titolo del Fondo Monetario né del suo direttorio. E parlerò un attimo della mia ricerca su quello che dicevi, Andrea. Lord Turner ha parlato in modo veramente straordinariamente chiaro della necessità di una transizione energetica. E ci sono colleghi qua a Washington del Fondo e anche della Banca Mondiale che si occupano di questo. Vi preannuncio, se non lo sapete, che nei meetings annuali di quest'anno sarà presentato un lavoro proprio da parte del Fondo sul cambiamento climatico e carbon pricing, che invito tutti a leggere e a studiare, e ci sono anche dei riflessi, credo, per l'Italia, con suggerimenti importanti. Il fondo lavora anche su adaptation, quindi come ci si organizza, per esempio, fiscalmente e strutturalmente nel gestire i disastri ambientali come quello che abbiamo visto nel caso di Dorian in questi giorni. La mia ricerca però si occupa più del nesso, come spiegava Andrea, tra clima e mercati alimentari, quindi clima e terra, uso della terra, uso dei mari. E credo che questo era un tema del quale si discute, ma non si discute abbastanza come della transizione energetica. Però gli incendi che sono avvenuti nel mese di agosto, che stanno prendendo ancora più piede attualmente in Amazzonia e nell'Africa centrale, forse hanno riportato un po' l'attenzione al link che c'è, è molto stretto, al trade-off tra per esempio allevamenti e anidride carbonica, emissioni di gas serra. Tra energy transition e transizione alimentare ci sono molte similitudini. Una è quella del carbon pricing, che nel caso alimentare ovviamente è pricing del metano, comunque delle emissioni emesse attraverso l'agricoltura, e quindi si possono fare dei paralleli di politica economica e di economia politica molto stretti. Lasciatemi chiudere, per lasciare la parola anche agli altri colleghi, dicendo che forse nel campo alimentare ci sono addirittura più co-benefici, nel senso che, come sappiamo, coltivare come si fa attualmente in modo convenzionale, con pesticidi, fertilizzanti, modificazioni genetiche, e ha portato a un'intensità e una produttività che hanno abbassato i costi, specialmente su alimenti che sono pericolosi per la salute umana, e le diete si sono spostate al consumo predominante di proteine animali. Se noi ci spostassimo, come la scienza dice, come dicono anche le Nazioni Unite in un recente rapporto, verso un consumo più verso una dieta mediterranea, che consuma meno carne, meno latticini, più verdure e meno prodotti raffinati, ovviamente la salute non solo degli italiani, che è forse migliore di quella di altri, ma globalmente migliorerebbe, ma migliorerebbe soprattutto la salute del pianeta. Quindi migliorerebbero le finanze pubbliche, lasciando grandi spazi di spesa per altre attività che sono importanti al giorno d'oggi, e ovviamente ci sarebbe anche più occupazione, perché quando si torna a un tipo di coltivazione organico con tecnologie intermedie c'è più intensità di lavoro. Quindi ci sono molti co-benefici, e spero che oggi ne possiamo parlare un po' nel corso del panel.
Ok, grazie Nicoletta. Nel frattempo ci ha raggiunto il senatore Misiani, grazie per essere qui con noi.
Grazie a voi, buon pomeriggio.
Grazie. Volevo sapere la tua reazione anche all'intervento di Adair, e anche poi alle slides che ti ho mandato, secondo alcuni temi. Ad esempio, Adair aveva parlato della possibilità di passare nel tempo a una produzione di acciaio a zero emissioni, quindi a me è venuto in mente ad esempio subito il dibattito sull'ILVA, oppure quando si parla dei costi di finanziamento di queste politiche, mi è venuto in mente, e su questo ha già commentato anche l'onorevole Castelli, sulla possibile riforma dell'IVA, l'aumento dell'IVA, se ci sarà o no, che è alle porte, o l'argomento dei sussidi dannosi, ovviamente anche altri temi che tu ritieni opportuno di discutere.
Allora, buon pomeriggio a tutti. Devo dire che ho trovato molti elementi che danno fiducia nell'intervento del professor Turner. Innanzitutto sulla grande sfida che abbiamo di fronte, l'obiettivo dell'azzeramento delle emissioni nette entro il 2050, del loro dimezzamento entro il 2030, gli obiettivi degli accordi di Parigi. L'intervento, la presentazione del professor Turner ci indicano una significativa fattibilità tecnica ed economica di quel cambio di paradigma che è implicato dal percorso inevitabile, obbligato, mi verrebbe da dire, di progressiva riduzione fino all'azzeramento delle emissioni, perché noi siamo chiamati ad una sfida gigantesca dal punto di vista non solo ambientale ma anche economico e sociale, un vero cambio del nostro modo di produrre, di consumare energia, di vivere la quotidianità di ognuno di noi. È chiaro che la precondizione per percorrere con decisione questo percorso obbligato è il progresso tecnologico, l'abbattimento dei costi di produzione delle energie rinnovabili, la fattibilità tecnica e economica anche della riconversione e della decarbonizzazione di importanti settori dell'economia. Il tema dell'acciaio in Italia chiama in causa inevitabilmente la vicenda della ex Ilva di Taranto, un insediamento produttivo di grande rilevanza con 15.000 occupati tra diretti e indiretti, la decarbonizzazione del settore della plastica chiama in causa altre migliaia di posti di lavoro nel nostro paese, e lo stesso vale per la produzione di cemento. Insomma, è un cambio complessivo che investe il nostro sistema produttivo, che dobbiamo sapere governare, andando con molta determinazione nella direzione indicata dagli accordi di Parigi, ma lavorando anche per rendere socialmente sostenibile la transizione ecologica. E questo è un tema di grande portata per i decisori politici. Nel momento in cui assumeremo, e dobbiamo assumere, una serie di misure di decarbonizzazione del sistema produttivo, di risparmio energetico, di interventi economici come quelli che voi avete ricordato, noi dobbiamo anche predisporre una rete di protezione nei confronti dei perdenti della transizione ecologica, altrimenti il rischio, ed è un rischio molto grande per la tenuta delle nostre democrazie, è quello di creare una nuova fascia di perdenti dal punto di vista sociale, che alimenterebbe ulteriormente il bacino della protesta, dell'antipolitica e di di movimenti antisistema che rischiano di erodere significativamente il consenso nei confronti delle istituzioni democratiche. Questo è un tema assolutamente da non sottovalutare, i costi sociali della transizione ecologica, e che vanno affrontati insieme alla predisposizione di tutte le misure necessarie per la decarbonizzazione dell'economia e il progressivo azzeramento delle emissioni di CO2.
Grazie. Giovanni, last but not least.
Beh, volevo dire due o tre cose.
Secondo me il microfono non va, devi parlare forte.
Hai cominciato dicendo qual è il ruolo del mercato. Io direi rispondo alla domanda qual è il ruolo del mercato e qual è il ruolo degli economisti. Io credo che il cambiamento climatico sia una cosa troppo seria per essere lasciata agli economisti. Essenzialmente il cambiamento climatico produce una esternalità negativa globale che non può essere prestata. Ditemi un prezzo dei morti alle Bermude, alle Bahamas, ditemi un prezzo sulla la distruzione dell'ambiente delle popolazioni indigene in Amazzonia, o anche ditemi un prezzo quanto vale l'ultimo panda. Tentare di prezzare e poi fare come gli economisti fanno, metterlo in una funzione di produzione, è una stronzata atomica. E così associata naturalmente è l'idea che si possono fare analisi costi-benefici, perché appunto è ridicolo o criminale prezzare per esempio la vita. Larry Summers perse il posto di Chief of Economic Council di Clinton nel primo giro, perché aveva appena scritto un paper dicendo: ma dove mettiamo tutte le robe inquinanti? Mettiamole nel terzo mondo, tanto la loro produttività è più bassa, quindi il valore della loro vita è più basso, e in ogni caso muoiono prima in ogni caso, quindi buttiamoli tutti là. questo è un tipico ragionamento da economista. Per fortuna quel giro lì ha perso il posto da advisor. Un po' abbastanza collegato a questo ragionamento è il fatto che la lotta al cambiamento climatico non è socialmente neutrale. Cioè, alla fine siamo arrivati qui come risultato di un'organizzazione capitalista della produzione e ancora peggio di una socialista che era ancora peggiore, in cui la natura è stata usata come una fonte praticamente inesauribile e va bene. Il Club di Roma diceva tanti anni fa moriremo, ci avremo limiti alla crescita per la scarsità di risorse. Purtroppo non è vero, ce ne abbiamo anche troppe, cioè ci soffocheremo nel petrolio prima di incontrare la scarsità. E nello stesso tempo la natura come una grande discarica, una sink, liberamente disponibile, e nel quale in tutto questo gli esseri umani non avevano e non hanno molto valore se non come lavoratori sfruttabili o consumatori. Secondo me, se non si lega il problema dell'inquinamento, che va dal CO2 alla plastica, al taglio dei boschi, delle foreste, alle miniere d'oro, ai veleni della Monsanto. Se non si va alle radici sociali, mi sembra che sì, mangeremo un po' meno carne, un po' meno fiorentine, e questo aiuterà un po', ma non credo che questo serva a impedire la catastrofe che è proprio, secondo me c'è un problema di timing. Come diceva Adair, ci sono molte non linearità negli effetti del cambiamento climatico, per cui c'è anche una teoria matematica che si chiama teoria delle catastrofi, ma se si passa il tipping point, poi non è che se si va indietro della stessa percentuale si ritorna al posto di prima. No, si rimane in un posto molto diverso e molto peggiore. Quindi per le ragioni di cui sopra e per l'urgenza derivante dalle non linearità, io credo che siano necessari interventi pesanti, non di mercato, sull'offerta. A me è piaciuto molto che Adair si sia soffermato sul lato dell'offerta e non quello che dovremmo tutti diventare vegani. Poi sulle misure ritornerò magari il giro prossimo. Comunque il messaggio è ci vuole delle misure di command and control ben al di là dell'uso degli incentivi e del mercato.
Grazie Giovanni, grazie ai nostri ospiti. Adair, do you want to comment on the comment that you received?
There were a lot of very powerful points there. Let me just mention two thoughts that come out of it. In terms of the employment effect and the fact that there will be new jobs and jobs lost, and that there is a transitional problem, I think we have to note that, and we need to be able to respond to it with appropriate policies to ease that transition without overstating the scale of the transition, because actually a lot of these shifts that have got to occur are no bigger than occur naturally within a market economy in any case. I was just at a conference of the Ambrosetti Foundation at Lake Como, and I was talking alongside the Polish Secretary of State for climate change. And we were talking about the challenge that Poland has with a large coal mining industry. But the minister made the point that Poland has already decreased its coal mining employment from 400,000 to 80,000, even before we address the challenges of climate change. So in a sense, yes, there will be a challenge of dealing with the loss of those final 80,000 jobs, but actually, you know, something 4 times as big has already occurred. And, you know, within our economies, we continually have churn of jobs being and gained in others. And so I think it's important for us to work out where the big numbers are and to have policies of retraining and help to manage some of these transitions, but without allowing the fact that there will be a transition to be a barrier to taking action. Again, when I think of the scale of the movement which occurred across Europe from the agricultural sector to the industrial sector between 1950 and 1970 or 80, this is actually a much more manageable transition. I don't have the figures immediately at hand for Italy, but I'm guessing that in 1950, maybe 25% of the Italian workforce was in agriculture. More. By 1980, that was 5%, and that transition was managed. Now, it is true to say we created intervention devices like the Common Agricultural Policy to help manage that transition. So we need to be aware of these transitional employment issues, but we also need to be confident that we have actually dealt with even bigger transitions in the past than some of them that we will deal with now. And my second point was on this issue of taxation and using taxation instruments. I think politicians need to think about taxation instruments which are simple and politically attractive, and that they need to be willing to do things which ministries of finance never want to do. Ministries of finance never want to, what is called, hypothecate action on one side to taxation on the other. When a Ministry of Finance sees the opportunity to increase a tax for environmental reasons, they love to be able to take that into the general pool of money and to make sure that it is spent, you know, under their control. But actually, to win some of these arguments politically, I do think we should be thinking about things like increasing gasoline or diesel taxes, or increasing taxes on aviation fuel, but taking that pot of money together and then returning it to citizens as a citizen's dividend. Because when you do that, you create a constituency of support for the taxation as well as a constituency of opposition. One of the problems is that every time we have a taxation introduced for environmental purposes, there are particular groups of people who feel that they will lose from it, so they argue against, but we don't have a natural constituency on the other side. But if you said, I'm going to increase this tax and this tax and this tax, and once we've got all these taxes, which incentivize environmental change, I will be able to give 500 euros a year to every single citizen as a carbon dividend, you will have a whole load of voters who will want more of those taxes. And this is an idea which is now being pushed in America by people within the Republican Party. On the whole, the Republican Party, I have to say, is a big problem on climate change now, but there are a minority of thinkers who are thinking about how to introduce carbon prices, carbon taxes, which all businesses have to pay, turning that into a fund which goes then back as a carbon dividend to early citizens, to make sure that there is a lobbying group of ordinary citizens saying, yes, I want my carbon dividend, to balance against the corporate lobby groups who will argue against. So I do think within the area of carbon taxation, we need to think creatively about how to make changes in the tax system attractive and to create political support for them. That's the only two I wanted to comment on.
Thanks a lot, Adair. So, cerco di essere adesso veloce perché Adair deve prendere un aereo alle 4:30 e la mia seconda domanda a tutti gli ospiti, no, deve prendere un taxi ovviamente, scusate. No, parte dal presupposto che il Regno Unito ha recentemente promulgato una legge per andare a zero emissioni di gas serra entro il 2050. La nuova Presidente della Commissione europea, Ursula von der Leyen, dice che la lotta al cambiamento climatico sarà una delle priorità della nuova Commissione. Allo stesso tempo, se uno guarda i fondi allocati per il nuovo programma per l'innovazione e la ricerca, il cosiddetto Horizon Europe, anche grazie all'ispirazione di Marianna Mazzucato, molti di questi fondi saranno allocati per missioni e alcune di queste missioni hanno a che fare con la lotta al cambiamento climatico. Quindi, tornando a quello che aveva detto anche Giovanni, ma anche quello che aveva detto Roberto all'inizio su un'industria 5.0, volevo chiedere ai nostri ospiti cosa farà il governo italiano nei prossimi mesi o cosa potrebbero fare le istituzioni internazionali o cosa potrebbero fare in generale i policy maker per decarbonizzare le nostre economie, se cioè dobbiamo attuare delle cosiddette missioni. Cioè il cambiamento climatico è una missione da affrontare, come lo sbarco sulla Luna, e quali sono le cose che si possono fare. Due idee che mi sono venute in mente sentendo l'intervento di Adair. Ad esempio lo sfruttamento della tecnologia dell'idrogeno. È difficile pensare che una singola impresa possa sviluppare queste tecnologie. Magari sono necessarie delle partnership fra il pubblico e il privato. Un altro problema su cui l'Italia ha dei gap tecnologici consistenti, secondo me, sono le batterie elettriche. È il caso di creare delle partnership pubbliche e private fra le nostre grandi imprese private e il governo per finanziare nuove tecnologie o lo sviluppo delle batterie elettriche e via dicendo. Quindi il punto è se è il caso di realizzare come missione politiche a supporto della lotta al cambiamento climatico. Possiamo partire, direi, da Roma a questo punto.
Beh sì, guarda, le idee sono tante, ma ce ne sono alcune che hanno funzionato. Penso che l'Italia ancora non ha l'Agenzia Nazionale di Ricerca come altri paesi europei. Oggi anche Conte in aula nel suo discorso di fiducia lo ha ricordato. Questo perché io credo che si debba in qualche modo accordare uno strumento unico come quello della politica e delle scelte che vengono fatte su un tema importante come questo, che oggi a livello internazionale è centrale, per cui ci stanno tutti questi ambiti, quello privato, quello pubblico. Oggi in autonomia molte partecipate hanno già deciso di fare alcuni investimenti perché sanno già che serviranno alla transizione. Accordare come un violino, come insomma le corde di una chitarra, tutti gli attori è quello che va fatto. Anche negli investimenti, con Antonio ne abbiamo anche parlato in questi giorni, un po' la nostra esperienza è stata quella, quando anche dai soldi per spese di investimenti agli enti locali e gli dai una missione come quella di riconversione, abbattimento di quello che è l'impatto ambientale, allora già stai facendo un'azione coordinata e su questo vanno montati gli investimenti, quelli più grandi, quelli delle amministrazioni centrali, delle aziende private, gli incentivi. Noi in quest'anno e mezzo abbiamo costruito questo sito incentivi.gov che racchiude tutti gli incentivi. Ecco, anch'io sono una di quelle che pensa che l'incentivo così tout court ha poco significato, invece accordato in una direzione, dicendoci tutti che si va verso questa direzione, ha come effetto un ottenimento più rapido e più veloce. Questa sensibilità io la sento, insomma, il Movimento 5 Stelle ha 10 anni di vita, io sto in Parlamento da 6, se mi ricordo 6 anni fa questa sensibilità non c'era così forte, quindi il momento è quello giusto e mi permetto di dire in una giornata come questa che anche il partner di governo è quello giusto, perché è vero che abbiamo avuto una certa lentezza nell'anno e mezzo precedente, questo per amor di verità.
Aggiungo qualche considerazione. Io mi sono riconosciuto molto nelle parole del Presidente del Consiglio, nell'impianto del suo discorso di insediamento, che credo sia stato il discorso di insediamento più ambientalista della storia del Parlamento italiano, in un paese come l'Italia in cui il tema dello sviluppo sostenibile è sempre passato in secondo piano nel dibattito pubblico concentrato su tanti altri temi. Oggi si apre una nuova finestra di opportunità, c'è una nuova sensibilità, c'è un asse politico-culturale condiviso tra i partner del nuovo governo. La legge di bilancio sarà il primo banco di prova di questa nuova sensibilità. Attraverso l'avvio di una revisione in senso ambientale del sistema fiscale, di un progressivo taglio dei sussidi ambientalmente dannosi e dell'avvio di un grande piano di investimenti per lo sviluppo sostenibile. È chiaro che tutte queste scelte non sono neutre dal punto di vista politico. La riflessione che veniva fatta in precedenza sul confronto anche aspro tra chi sente di perdere da queste scelte politiche e una platea più ampia e meno concentrata di persone che invece guadagneranno da una politica più orientata verso lo sviluppo sostenibile è un tema molto importante. Nei prossimi mesi ci sarà un confronto anche duro in questo Paese in relazione ad una serie di scelte anche difficili che il nuovo governo sarà chiamato ad affrontare in tema di fiscalità, di taglio dei sussidi e di riorganizzazione delle politiche pubbliche nel nostro Paese. Ecco, io credo che sia indispensabile da questo punto di vista una vasta mobilitazione sociale a sostegno di una svolta ambientalista delle politiche del governo italiano, perché in assenza di questa mobilitazione io credo che le tante resistenze che si manifesteranno nel Paese, insomma, daranno filo da torcere al nuovo governo, che è atteso ad una prova molto importante di visione e di tenuta politica nella direzione dello sviluppo sostenibile.
Grazie mille. Nicoletta?
Volevo un paio di parole per riprendere l'intervento di Giovanni, che mi è piaciuto molto. Sono molto d'accordo con lui che le tasse non sono tutto, non possiamo convincere tutti a muoversi in modo razionale reagendo con le elasticità di domanda che conosciamo a nuovi prezzi. Ci vogliono interventi regolamentativi, c'è stata credo una conferenza anche in Vaticano col Papa Jeffrey Sachs e altri in cui si è parlato della necessità di agire in modo regolamentativo, non solo attraverso un nuovo prezzamento delle esternalità. Sono un po' meno d'accordo sul discorso che le diete non avranno un impatto importante. Volevo citare due dati, anche vedendo i rappresentanti di Senato e Camera che li vedo molto lanciati, e grazie a Dio, a questo tema dell'ambiente che secondo me per l'Italia è importantissimo. Questo nuovo studio delle Nazioni Unite della International Panel of Climate Change del 2019 ha calcolato che nuove diete, cioè diete più consone all'ambiente, più sostenibili, potrebbero cancellare emissioni per l'equivalente annuale di Stati Uniti e India insieme. Solo migliorare la nostra perdita di cibo, cioè food waste, taglierebbe un altro 8-10% dalle emissioni globali. Stiamo parlando della somma delle emissioni di Russia, Giappone e Germania. Quindi sono cose enormi e tra l'altro noi dobbiamo preservare queste aree di biomassa, no? Come le foreste amazzoniche, perché se non le preserviamo il nostro obiettivo di mitigazione contro la transizione energetica diventa molcile, perché in questo momento stanno assorbendo CO2, quindi le nostre proiezioni business as usual prevedono che queste biomasse rimangano integre. Un paio di parole su quello che dicevi Andrea sul mission oriented, soldi della Commissione europea e il budget europeo. Personalmente come economista, ma lo dico anche così da cittadina, mi sembra forse il massimo di investire in tecnologie, anche se la tecnologia italiana è molto avanzata, non so qual è il guadagno marginale di dare più soldi per studiare le batterie. Ci sono a livello globale grandi imprese come Tesla, anche Toyota, sono molto avanzate. Forse come cittadini globali, come paese che partecipa in modo coordinato a questa transizione energetica mondiale, insisto, è opportuno lavorare anche su cose tipiche del nostro territorio, cioè magari creare delle regolamentazioni per il retrofitting urbano. Lord Turner ha parlato dell'importanza di regolamentare le costruzioni. Noi abbiamo tante cose storiche che magari possono essere rese più efficienti e consumare meno energia, molto patrimonio anche dell'UNESCO. Senz'altro ridurre i sussidi che portano a diete sbagliate in Italia e all'estero. Abbiamo avuto nei governi passati, non questo subito passato credo, ma quello prima, avevo sentito non mi citate, ma avevo sentito di sussidi importanti, milioni di euro a allevamenti intensivi. Abbiamo avuto reports della Gabanelli sulla condizione in cui sono tirati su anche questi animali. Io credo che c'è molto da fare nell'agritech. L'Italia è un paese a connotazione, cibo e benessere sono al centro del nostro paradigma culturale e di cultura viva, e quindi perché non investire e fare una grande mission oriented dove l'Italia diventa un polo di competitività organica e di dieta esportabile a livello mondiale.
Grazie Nicoletta. Giovanni?
Adesso va di moda parlare di mission, però la mia sensazione è che a livello europeo sia una mission un po' anacquata, un po', cioè le mission sono un governo che stabilisce degli obiettivi di ricerca e degli obiettivi tecnologici per raggiungere un risultato, che non è ti do un incentivo per fare qualcosa che fa bene al clima, ma è il progetto Manhattan. Il progetto Manhattan o il progetto Apollo. In questo caso potrebbe essere idrolisi. Voglio che voi saltate fuori con nuovi metodi o miglioramento dei metodi dell'idrolisi. Quindi c'è un obiettivo tecnologico e sì, poi ti pago per farlo. Non è vienmi a dire che cosa vuoi fare per l'ambiente e io ti do i soldi, che è stata la vecchia filosofia dell'Unione Europea, molto più cara e molto meno efficace invece delle mission. E le mission sono un po' come le guerre. Cioè, Nixon quando fece la National Institute of Health, non fece naturalmente nessuna analisi costi-benefici, ma dice dichiariamo guerra al cancro. Se dichiari guerra naturalmente non devi fare costi-benefici, ma c'hai un obiettivo. Lo stesso dovrebbe essere per progetti orientati alla CO2, ma anche agricoltura biologica, tante cose, sostituzione delle plastiche, cioè obiettivi stated ex ante dal governo, poi chi li fa, se saranno già in venture privato pubblico, sarà il privato che fa procurement per il pubblico, la struttura è variabile, ma è l'idea che ci sono obiettivi che non transitano dal mercato. E questo naturalmente è complementare all'uso degli incentivi, ma gli incentivi sono utili essenzialmente per la diffusione di tecnologie che ci sono già. Per la generazione di tecnologie che non ci sono ancora, gli incentivi funzionano malissimo e sono molto cari.
Grazie. Giovanni, Adair, if you want to comment, and then I think that Roberto can close the meeting.
Let me make a comment both on this issue of mission-driven government support, and then another one on the points that Nicoletta raised about food and land use, which I haven't mentioned before. I think there is a role for what Giovanni's been talking about, which is defining very clear objectives of crucial technologies and then being willing to support those with public money in the early stages of their development. And indeed, there are successful examples of this. The Department of Energy in the US is a very major funder of research and the early stages of development, close to commercial development, but not full commercial deployment. And back in 2010, it defined a mission. It said today batteries, lithium-ion batteries, cost about $1,000 per kilowatt hour. We will have a mission that it is below $200 a kilowatt hour by 2020. And we stand ready to give support to projects which look as if they are addressing the science and the engineering in a way which will help us take us in that direction. And the good news is we ended up getting there 2 years early because, as I showed on my earlier chart, batteries actually went below $200 per kilowatt hour in 2018. Now, I think I would agree with Nicoletta that actually we are at the stage where, certainly with the standard lithium-ion technology, we don't need more support because there is huge amounts of private investment going on. We've gone through a turning point, and that includes huge investments here in Europe. If you look at Northvolt in Scandinavia, if you look at CATL, the big Chinese company, they are doing a big investment in Erfurt in Germany, Volkswagen. Every single person in the automotive industry is piling money into the battery development and the cost reduction of the existing lithium-ion technology. So, in respect of how do we get the energy density of standard lithium-ion technologies up from 300 watt-hours per kilogram to the theoretical limit, which is about 500 watt-hours per kilogram, or drive the cost down, I don't think there is much of a role left for the state there, because I think we've been successful. The private sector is now incredibly focused on that. On the other hand, I think there probably is still a role for public money to support the breakthrough technologies which would take us to a whole new level of energy density, and therefore I think we could support that. And I think also in the areas of hydrogen electrolysis and fuel cells, they are still back at the same area where, the same point in development where lithium-ion batteries were 10 years ago. So I think there is a role, but one has to, one has to switch off the role when you've achieved your objectives. And broadly speaking on electric vehicles, I think the electric vehicle, is going to happen. And insofar as there is public money to support electric vehicles, I think I'd now put it into one thing, which is charging infrastructure. I think the automotive companies are driving the development of the battery technology fast enough that range will continue to improve. I think they're driving down the cost. I think by 2024 there will be EVs available with 400-kilometer range, which will be cheaper to buy than the equivalent ICEs. And so I think the role for public support to subsidize the purchase of a new EV can begin to be phased out. On the other hand, if we don't have more charging infrastructure, that is where the bottleneck now is. So you have to think very clearly about what we've achieved so far and where public money will have a major impact. And then if I could just comment on the food, the land use area, I didn't comment on it in my lecture. It's not an area where we have focused a lot, but we know it is very, very important. In the UK, emissions from agriculture are probably now about 15% of our emissions, because there used to be sort of 8% of emissions, but the other emissions are coming down. So this is part of the problem we've still got to deal with. The two big issues are methane emissions from ruminant animals, particular sheep and cattle. And there are very good reports out by the IPCC, also by the Lancet, the medical journal, setting out the dramatic differences in the climate impact of different forms of meat. Basically, beef and lamb has a far bigger climate impact than pork or chicken, which also, however, are higher than quasi-vegetarian diets. And the other big issue is land use change, which again is heavily driven by beef cattle development and, fundamentally the process of knocking down forests to grow soya, to put into beef, to turn into cattle to turn into beef, is an environmental disaster. So I do think we need a vision of how we're going to address this. If you talk to some farmers and farmers' unions, they will tell you that there are technological fixes to the methane production problem. I don't think there are in terms of complete elimination. I think there are reduction things. And this is one area, I have to say, where I think there will need to be, and there should be, and we should encourage a bit of a behavioral change. I think getting people to move away from the large-scale consumption of ruminant meats, to reduce that in their diet, and perhaps to switch to the point of view where, yes, they are eating, meat, and in particular beef and lamb occasionally, but it's something where you buy the very highest quality of organically produced beef or lamb on an occasional basis, rather than consuming it on a larger quantity. Now this is a tricky area, because unlike in some other areas, we need changes in behavior. It is true to say that those changes in behavior are already occurring in some societies, at least in Britain. Among young people, we are seeing quite major changes in diet. The other thing is, in agriculture, I do think some of these new technologies could end up very important. The production of artificial meats by Impossible Burger, there are two routes forward, one of vegetable-based meat substitutes, the others are actually stem cell-based ways of creating the biochemical equivalent of meat. These have gone through an extraordinary breakthrough already. I mean, when the first burger was produced by these technologies 5 years ago, people were joking that the cost was $200,000 a burger. They now have a premium against standard burgers of about 50%, and I wouldn't exclude the possibility that these artificial meat substitutes may be cheaper than meat within 50%. And I suspect they will make a big impact, not on how people eat steak, but on how people eat burgers. And that actually would be, I think, a very good development. But I just wanted to highlight that the totality of issues around food and also land use for bioenergy production, one of the things that we do in our report is try to develop an idea of what is the maximum amount of energy we can produce from biomass resources without that in itself being unsustainable. It is a very difficult area because the range of estimates which are out there in the literature are enormous. There are some people who say that we can produce no more than 50 exajoules of energy. That's about 16,000 terawatt hours from biomass sources. There are other people, including the International Energy Agency, who have estimates 3 times that. We think we've got to be very cautious to make sure that bioenergy is not itself producing more problems, even while it contributes to dealing with climate change. Indeed, it can be very bad for climate change. If you tear down forests to produce palm oil, that is a catastrophe for climate change. And what that means is that with bioenergy, we need a very clear sense of what is the maximum sustainable budget for bioenergy, and how do we then use it in those sectors of the economy where there are least alternatives, but not where there are alternatives. And I have to say, that would imply to me, I would remove all subsidies for the use of biofuels in road transport, because I think there are alternatives for road transport decarbonisation, whereas I would probably support the deployment of biofuels in aviation, because I don't think we have alternatives. But I think one needs that sort of systematic approach to that issue.
Okay, well. Thank you very much to everyone. Thank you to the panel. I just want to say a couple of words. First of all, I want to thank the rector, Sabina Nuti, for having hosted this very, I think, important meeting. I want to thank the project, the European project GROWINPRO, who has been funding this meeting. I want to thank a few people here at Sant'Anna, especially Barbara Torelli and Laura Ferrari, who has organized in an excellent way everything. I want to thank the people in the technical box and the translator who has made it possible that we that everyone could follow it. I want to thank our guests from Camera dei Deputati, Onorevole Castelli, Onorevole Misiani. Thank you very much. I want to thank Nicoletta from IMF. Thank you very much to you as well. Thank you, Giovanni, for being here. Thank you, Andrea. Thank you very much, Adair. I would conclude by saying that we heard that we can deal with climate change. We have the technology. It doesn't require a huge amount of investment. We need the political will to do it. And if we work all together, scientists, economists, politicians, and we drive it, I'm sure that we can reach what the world asks us, what the next generation, the young generation, asks us to do, which is to really decarbonize the economy. And with this, I think I'll close the meeting, and thank you very much to everyone. Where is coffee outside for everyone? Andrea.